Hello, guys. Welcome to Ramcha Solutions. Welcome to your grade 11 physical sciences exam prep. So, today, the question paper that we're looking at is the Eastern Cape's November 2023 Physical Sciences Paper 1. Okay, of course, we are still in vectors in 2 dimensions. So, as is a norm, we begin by reading instructions. Remember, all of them are important. Okay, all of them are important, but we're going to highlight just a few. So, check this out. Instruction number 8 says, show all formulae and substitutions in all calculations. Instruction number 9, round off your final numerical answers to a minimum of 2 decimal places. Now, what this means is that, or rather, we should add a tip on this. When you have your calculations, sometimes in the middle of your calculations, you will have very long decimals. So when you work with such, at least in the middle of your calculation, round off to about 4 or 5 decimal places in the middle of your calculations. Then only round off your final answer to 2 decimal places. If you can do that, you will get the exact answer that your memo provides. Instruction number 10 says, give brief motivations, discussions, etc. where required. Guys, with this instruction, it doesn't mean that you should stress yourself because maybe you don't have the correct wording that you think you require. Any wording that you think makes sense and is scientific, provide it. Okay, provide it. But make it brief if possible. But however you can, please make sure that your point is conveyed. Okay. And of course, I have ignored this for a while, but it's important that we look at it. Instruction number 12. You are advised to use the attached data sheets. Of course, this is where you get your equations and the constants, right? If you do not know your constants, quickly rush to the section. Let me show you, for example. Quickly rush to your constants and you will find them. For example, constants. Here is it. Acceleration due to gravity, universal gravitational constant, speed of light, Coulomb's constant, mass of an electron, mass of Earth, radius of Earth, for example. You go to your formula sheet, especially here, to get your constants. Then you then go to your equations, your formulas. You want to know which formula to use. They are provided. All right. They are provided. And you'll be good to go. All right. Perfect. Now, this section that we are in, the topic that we are in is normally question 2. All right. So let's go there. Question 2. All right. Perfect. So this is question 2. All right. So let's read the statement. So this is 13 marks. We must be done in 13 minutes. Right? We must be done in 13 minutes. Okay, let's go. So 3 forces, force 1, force 2, force 3 are applied to a crate of 15 kilograms as shown on the diagram. So as shown on the diagram below. Okay. So define the term resultant vector. Very cool. When they say resultant vector, we know it is sum of 2 or more vectors or a single vector having the same effect as 2 or more vectors added together. A single vector having the same effect as 2 or more vectors. I can squeeze it here. As 2 or more vectors added together. Alright? Added together. Okay? Perfect. Otherwise, we can also say it is sum of 2 or more vectors. I like this one. I like this one that I wrote. Okay, 2.2. calculate the resultant of the three forces. For this one, I just want to draw this so that you guys can see what we actually need, because I don't want to complicate things here. A lot of times when students come to this section, they can fumble it. So I want you to see something here. Let me use different colors. So I'm gonna use green to focus on this one, F1, which is 500. Right, so this is F1. So I want you to see something. This will be F2, F1x. Okay, this will be F1x. Oh, hold on. It is not that. It is not that because the angle is not there. Let me write this F1 here. So the angle is here is 30 degrees. All right. So this will be the x. So this will be F1y. Sorry, it's not the x. This is F1y. Then the head to tail method. This will then be F2x. Do you see this? All right. I'm going to change the color again to show the F2. So this is the F2. Okay, this is the F2. Okay, F2, I can write it here. So here it is 50 degrees. So obviously the X will be moving this way. This will be F2X and the Y will be this way. So it'll be F2Y. Okay. Then of course we also had the F3. It is horizontal, so no worries. Do you guys see this? Perfect. So now what we are going to do now, we are going to say for the horizontal, because they say we must find the resultant of the three forces. So for the horizontal, all right, for the horizontal, let's call it Fx. Okay, let's call it F, or since it's a resultant, let's just say R in terms of X, whichever you prefer. Even if you say F sub R, maybe let me say F sub R, because yeah, let me say F sub R in terms of X, it'll be, this is a Cartesian plane, and this being a Cartesian plane, you know, these are positive X values, negative X values. So this means we have let's say we have F2X plus, not F2, F1. This is F1. This is F1X. So we have F1X. Alright, we have F1X plus F2X minus F3, isn't it? So what do we say? What is F1? F1X, when you look at this angle here and the side, this side is opposite. And this is the hypotenuse it is given. So we will say it is sine. So we will say, just to give you a hint, we will say it is okay, we will say this is sine 30 degrees equals F1x over F1. Therefore we can say F1x equals F1 sine 30 degrees. I'm sorry, I'm squeezing it. Okay, sine 30. So all of them, we're going to look at them in this way. Okay, so F1x, going back to using black, it'll be, we said it is F1 sine 30, right? It is F1 sine 30. It is F1 sine 30 degrees. What is F2? F2, as you can see, this is adjacent. So it's not gonna be sine, it's gonna be cosine because it's adjacent and hypotenuse. Using cos 50 over F2x over F2, we can then say F2x is F2 cos 50 degrees minus F3. So whichever you prefer, whether you use this one here or this one here, it's okay. Now let's remind ourselves, F1 was 500. It's 500 sine 30. 500 sine 30. And then F2 is 600 sine, not sine, but cosine, cos 50 degrees. F3 is 450, so minus 450. Now, this becomes 500 sine 30 plus 600 cos 50 minus 450. And this is 100. I know it's tempting, guys, to say this is 185,67, but this is not the final answer. So I'm going to say 185,6725 or 256 or maybe 26. Yeah, 26 newtons. Okay, where it is positive on the positive x-axis, isn't it? Positive x-axis or to the right. Then let's look at the vertical. Let's look at the vertical. So for the vertical, I'm gonna say fr comma y is, it's gonna be f1. As you can see, f1, let's see, f1y is going up and f2 and then f2y is going down. F2y is going down, isn't it? Can you see that? It's going down. So hence it is f1y minus f2y. Then what do we have? F1, let's see, F1, this is adjacent and this is forget this is adjacent and this is hypotenuse, right? So adjacent and hypotenuse, we're gonna say cos 30 is equal to f1y over f1. So since we said cos 30, we can therefore say this must be f1 cos 30 minus f2. Let's go back to check. F2, this is opposite and this is hypotenuse. So we'll say sine 50 is equal to f2y over f2. So we can therefore say f2y is f2 sine 50 degrees, isn't it? Right. Now let's see. F1 is 500 newtons cos 30. F2 is 600 newtons sine 50. Let's get our answer. Let's get our answer. It'll be 500 cos 30 minus 600 sine 50. So what do we get? We get a negative 26.6140 Newton, which is 26.6140 Newton, negative y-axis. I'm going to say negative y-axis. Okay, negative y-axis. This is the direction, right? Because we said y. Now the resultant, before we go there, I want you to see this. This is your thing here. It goes like this. And this is your thing here. Your x, it goes that way. All right. This therefore tells us that the resultant must be coming this way. Your angle, very tempting. Your angle, I want to think of him to be here. Okay, I want to think of him to be here. Okay, I want to think of him to be here. Okay, now since he's here, we are good to go. We can also say, you see, with what we have here, we have something like this. So this is this is f r y, f r x, and then f r. Okay, so now what we are going to do now, they said the resultant. They didn't say magnitude or they didn't say whatever. They said the resultant. Knowing that this is a force, it is a vector quantity. We need magnitude and direction. So the resultant will be, Pythagoras theorem will be frx squared plus fry squared, isn't it? So what is frx? If my memory serves me well, it was, it doesn't serve me anymore. 185,6726. 185,6726 squared. And this guy, yes, it serves me indeed. Minus 26,6140 square, isn't it? All right, perfect. So let's get our answer. 185,6726 square plus 26,6140 square. What do we get? What do we get? We get 187,57 newtons. Okay, we are not done. Okay, we are not done. So since we are not done, we will need, since we are not done, we will need, we will need a, we will need a what? We will need to find the direction. Now to find this direction, we will say, again, I prefer to use opposite over adjacent. Right? Opposite over adjacent. That's tan. Okay, that's tan. So tan theta equals FRX over FRY. Please ignore the sign for this. Okay, please ignore the sign. So this will be theta equals tan inverse of FRX over FRY. And what is this? This is tan inverse of 185,6726 over 26,6140. 26,6140. Let's see now. 185,6726 over 26,6140. Now what do we have? So now we have, when you ignore the sign, you have 81,84 degrees. Therefore, the resultant, therefore, the resultant force is, what is it? The resultant force is 187,57 newtons. Let me say at 81,84 degrees clockwise from the x-axis. Okay, clockwise from the x-axis. So when I use this clockwise from the x-axis, this is what I get. Okay, this is what I get. All right, guys, this is it. So we tried to explain how to do this question because it is one question that a lot of you really would make a mistake when it comes to this. Okay, a lot of you would make a mistake when it comes to this question, but we are not done. So 2.3, explain why the three forces will not form a closed vector diagram. Why will they not form a closed vector diagram? This is because the resultant is not zero. Okay, this is because the resultant is not zero. Okay, because the resultant is not zero. Maybe let me just write it like this. It's not 0, 10. Okay, as simple as that. If the resultant was 0 newtons, meaning they were in equilibrium, this is when they were gonna form a closed vector diagram. Okay, all right, guys. So remember, if you would like to follow us, on the description of this video, you will find links, including WhatsApp channel. You can follow us on WhatsApp. We will be uploading some exam tips and also updates that we make on YouTube. We will update you on WhatsApp. You can visit our websites and social media platforms. The same applies to if you're looking for a tutor. You can also check us out on our WhatsApp, and we will try to assist you, and of course to help you get your desired results. All right, so with that being said, it's a wrap, and bye bye.